Yep.
Let me know if you're seeing anything.
Yeah, I can see that. Yeah, you can go ahead.
I'm trying to see if I can expand this one. I think, did I expand it? Okay, so I think you have heard from our distinguished speakers about a lot of things about the metaverse, and I'm going to go into a little bit of a mundane part of this metaverse, which is the underneath the metaverse, basically the plumbing situation, and how does the metaverse can be founded based on the technology. So a few things that I might like to discuss is, first I'll give you a very simplified view of my you know, structures here for the metaverse, how the metaverse could be, what do you call, supported by the technology underneath. And then we're going to talk about a little bit on the needs, and then I'm going to argue a case for the edge networking, especially with the security, and few challenges also both in the security side and as well as in the edge networking side. And that's pretty much going to be my topic of discussion. I would welcome any questions as you see appropriate. I'd love to discuss those things further. So what you see here is kind of a two layers in shown here again in the 2D world, but it's actually meant to be for the 3D metaverse. In the top, all the wonderful things that you just heard about, all the non-fungible assets and so forth, and also our digital twins, avatars, and all the marketplace that we're going to be operating on this kind of plane. That's a 3D type of plane that is going to be operating now. How this is going to work? How is it going to be supported? In the physical world, we exist here with our gadgets, all kinds of gadgets and exciting gadgets, all including even some of the haptics. And now they're going to be powered through different engines like AI/ML engine. Artificial intelligence is a key. Without that, we can't even move anything anymore. There is going to be game engines, and then we have some networking infrastructures that we see today as the large cloud data centers, as well as also some virtualization of the network itself, because the network needs to be very flexible and reconfigurable through the software and needs to be very fast. So that's where the SDN technology and the NFV technology comes in. And now on the networking side, there are two major domains. One is like a wide area network domain, and that's basically is being powered by the 5G and the 6G. After the 5G, we're already entering kind of in the 5G plus, or we're experimenting in the 5G plus type of situation. And then we're going to slowly migrating to the 6G. Now, this is, if you're following the 3GPP, third generation partner projects, who is responsible for standardizing all these things worldwide. Their release 18 is going to be targeted towards the 2024, about 2 years from now. Release 17 just got released. So that's kind of release 17. I see it as more like a 5G plus-ish type of, and then release 18 and so forth. We're going to be entering into the 6G world. Now, so these are the foundation, and there is going to be a communication between these two layers. And I call the lack of better terms is some sort of an API. Think about it like an API or interfaces. And these API, and we're living in the API world today. So I don't think that's a new terminology for anyone. So we're going to be seeing that all the digital world and the 3D virtual world that is going to be connected, that is going to be powered through the API that is going to be getting all this wonderful technology behind it to make that happen. Now let's go into the main objective on the metaverse. Now, one thing is very clear, that it's going to be all about extremely good experience for the user. So in the primary key there is the real-time or near real-time experience. So just like we live in the physical world, we like to have we are habituated with some sort of an interaction among ourselves, which we call real time, right? Barring the human response time, but we are not used to taking too much of a latency and waiting for something to happen. So that similar thing, I think we may have to notice in the virtual world, although it's extremely hard to do. And that's what is being said in this slide. Basically, I'm pointing out that thing. So the mapping between the physical world to the virtual world is a key, and how fast that is happening, whether if we have a digital avatar or digital representation in the digital world, that needs to act as if like we, in the physical world, however, we are expecting a response time. So saying that, now what are the things that we'll be seeing here? Okay, so this is kind of a typical scenario on the application bandwidth in the game industry. You might be experiencing right now about the 3 meg type of bandwidth, and the latency at about 150, but these are going towards the 82. Let's say in the VR world, you're going to be VR and AR world, you're going to be in the 80 to 100 megabits per second. It's already happening. And your latency expectation is going to be in the tens of milliseconds, meaning about 30, 40 milliseconds, maybe 50 and such. So some of these are coming from the industry that they are experiencing around 10 milliseconds. They're expecting in the AR, VR, and MR world about 10 millisecond type of latency. Now, on the bandwidth wise, we are moving towards the more like a gigabits per application. 10 gigabits per usage is practically, basically is what is going to be needed. 100 gigabits is not too far out of the question. And this is going to be happening also in par with the demand that we have from the 6G world, which will be approaching towards more like the 3G, what do you call it, the 6G world. So a distributed edge scenario for the metaverse scenario. Okay, so this, I don't know why I think I'm in the wrong slide. Bear with me a little bit here. I don't know how I got into that one. I am supposed to be on this slide here. Share. Okay, let's see if I got into the right slide now. Okay, so I think if you're seeing my screen, right?
Yeah, you can go ahead.
Okay, so I'm going to move in. And so I think I went over this one, and I also went over this. And so I'm going to move to the next slide. This is the slide I was looking for. Distributed edge scenario for the Web3 metaverse. Now, I envision that basically the edge networking scenario is going to get more complicated, and it needs to be much more distributed because it needs to be scalable when you're supporting something like as humongous as metaverse. And what that means is that you will have edge nodes are typically resource limited, right? They are next to your 5G or 6G cells tower, and they have very limited space of the resources. So what you need to do is you need to basically interconnect those cell towers and the edge node behind them through efficient networking, but they could belong to the different carriers. So one could belong to the carrier one could belong to the carrier two as such. And there comes the jurisdiction billing scenario and all kinds of things. So there is a lot of complication as far as scaling outside of one carrier jurisdiction going to this next carrier jurisdiction as such. But however, if the edge network is going to support something like a metaverse in a seamless manner, that's what is expected. So, just like anything else, metaverse is also like some layers. And you might have some sort of regional metaverse that is carried over the carrier one, and there are other regional metaverse that be carrier two, and they could be all integrated through the network again in between the cell towers. Either you could travel through all the way to the core network, but that will add some more additional latency. But it would be preferable that your regional networks can talk to each other and reduce the latency. It's all about the latency. And when you move to the edge, basically all you're saying to the world that, okay, look, you can do the things in much more closer to your near real-time experience than you see typically in an internet world today, or today's world, because that goes through the core network and that goes all the way back to the cloud data center, which adds a tremendous amount of latency, at least 100 milliseconds, 80 milliseconds, that kind of latency are being added. So you wanted to avoid that scenario, you would probably envision something like this kind of scenario, which is distributed edge. And there are Wi-Fi 7 technologies also going to improve on the latency and improve on the bandwidth, as well as like the 5G to 6G migration in the wide area network is also going to improve the latency. So going to the next one. So in short, we're basically seeing some evolution towards the edge paradigm. Some of the things that we're expecting is extreme performance we're expecting, and that's primarily the hallmark of the edge. You are looking for a significant improvement in the performance compared to, for example, a cloud-based scenario. And then the other part is the software definable and composable infrastructure. Everything has to be software definable, whether it's code defined and so forth, but it needs to be dynamic. It needs to be possible that as you wish. It's also somewhat of a virtual world within the network itself, like the virtual containers and the virtual machines, and those kind of things are going to exist. And then you will have applications that are much more optimized for the edge. So those, we call it edge native. And some of the developments are already started. For example, API centric or API first type of development, DevOps basically is going on that to create those kind of scenarios. And also, hybrid cloud edge infrastructure needs to happen. So containers, microservices, and connected to a service mesh that connects all your microservices to complete a application that is going to be essential in the edge arena. And if you look at this, the case that we can make, or the argument in favor of edge, is basically it's about the real-time experience. Why? Because you do get the lower latency and also higher bandwidth that is needed for all the applications that we see in the metaverse concept. Distributed architecture, basically on a federated manner, most likely, and also maybe a peer-to-peer that is necessary in order to scale. Now, scalability with decentralization and disaggregation, which is basically very, very important, because you don't want to have a scenario where you're running out of the resources and you have to stop your application service that you are providing, and you need to move and provide those resources from the next node. And these arrangements are extremely going to be done. This is extremely hard. And these are going to be based on a very complicated load balancing scenario. But through the artificial intelligence, AI, ML, I think there are hope that we would be able to do that and maintain SLA. And I have a slide probably after this, that might allude to some of this. Virtualization is key, because that's the programmability, that's the definability of the network creation, like network slicing. You have to create slices of networks that are dedicated for certain applications, and that applications are basically going to be the key for your applications that for your services that you are going to be providing. So automation, wireless ubiquity, those are all the things that you need. Now, there are challenges. The challenges, as I mentioned earlier, about the scalability going beyond the local edge node. Now, normally, of course, anytime you provide a service, you have certain kind of an SLA or a KPI conformity that you need to do. The SLA means service level agreement. So if you go with the carrier, you are paying certain amount of money, you expect certain kind of services that has some matrix that it needs to conform. So those metrics must be maintained even if you're moving or scaling horizontally from one node to the other node, and which is physically located in a separate location, maybe in about, let's say, a few 100 meters away, or maybe 1,000 meters away when you're considering distributed edge scenario, right? So how do you maintain your latency when you're injecting certain additional latency as you're moving to the next node? You have to obviously cleverly do your load balancing. You do not necessarily have to have the same latency for every task that is going on in your instances that you are creating within your resources and compute resources or the storage resources as such. And so you need to be able to maintain a properly designed a matrix that you already agreed upon, using the AI/ML to know which resources would be most applicable. And that means also resource management optimization. You need AI/ML assistance there. And also, it's extremely important that when you're roaming, meaning you're going from one node to the next node, even though you physically are not moving, but your load, the application that you are using, is actually moving from one edge node to the another node. And that there cannot be any interruption, right? So that needs to be maintained. Now, a couple of points on the security. And the security is basically very, very essential. It's almost embedded in every application that you do. So now that we have a metaverse level, in addition to our physical level, we have two levels of at least thinking of security. Now, the in essence of the security is not any different in the virtual world versus the physical world. So the security boundaries, just like your identification, access management, integrity protection, using the trusted, module, trust module, confidential computing, those kind of things need to exist. Of course, they're happening in the physical world, and in your engine that is powering all these devices and the both infrastructure, both the physical and the virtual infrastructure. Now, the containerization, we already know a ton about how to secure those containers in the Kubernetes world. When you orchestrate them multiple clusters, and they need to be secured, so the traffic between the east to the west needs to be curtailed properly. Or some of these containers, there are activities now in the standardization, they're called kata container, that are actually a confidential container. So, so these containers are not even seen by the host machine, for example, that is running these containers. So there are a lot of things happening, and some of these things have to be utilized. This is not a one size fit all type of security solution. So there needs to be basically orchestrated and based on your load and the user and the applications that you are using, how sensitive they are to the security. And the other parts we know, microsegmentation, domain slicing, user plane integrity. Of course, we have to maintain those things from the denial of service, certificate of management through the certification management, and also DNS protection. Supply chain protection is another big key that everybody is looking at. And these are basically your softwares that are going into your application software, as well as the physical infrastructure, physical entities. All those things fully have to be protected. There is all kinds of signature verification. There is what do you call integrity verification. Those are all being happening. And key obviously is zero trust. So if you have a zero trust mechanism for all your security things, then you are doing a lot better, because you are assuming that your attack surface can be anywhere. So you're not necessarily isolating any attack surface and thinking mistakenly that that surface is protected. So some of the additional security considerations are basically extremely important in the metaverse context. Is how do you optimize the performance in the metaverse world, right? while you're hardening the access control and encryption, because every one of these security measures, like it or not, has some pricing associated with it. So these are primarily latency pricing, right? Anything you do is an encryption or you do an identification, verification, and so forth, like that will consume some latency. So how do you make these things happen so that it still maintains the real-time expectation or near real-time expectation by your users? These are going to be the key challenges that we need to sort through as we embark on this world. Distributed edge also brings up a lot of security solutions because you're going beyond the one jurisdiction to the other jurisdiction, and there are securities are different or controlled by different jurisdictions. So how do you integrate them? How do you make it almost looks like a seamless from the user perspective? Application solution security needs to be balanced against the KPI. This is basically earlier we talked about just the latency and the power budgets. Multi-layer virtualization. This is going to happen even in the metaverse world. Like we already saw in the physical world, we do have virtualization with the SDN and FB virtualizing the network entities. There are physical network entities, there are virtual network entities. So these all exist, and there are physical processors, there is also virtual processor. Now these are all residing in the physical world. However, in the metaverse world, as it is supporting the metaverse may also have layers of virtualization depending on how we orchestrate those. So we need to keep that in mind. And there is going to be different kinds of attacks also that we may not have seen right now through the help of metaverse in some ways, because people may be able to attack through the virtual entity like your avatar and so forth, and make the avatar feel like as if if you're walking through a street or something like that, you are mistakenly falling down even though you are actually not falling, and that causes a hiccup towards your interaction towards the human or the physical world human that is, or the user that is actually being affected. So how do you prevent that thing happening? Those are very, very important considerations that we need to do. Let's see. So some of the resilient edge hardwares are being developed. That is probably to keep in mind that we have seen multi-core processors with next generation, and right now it's on the 12th generation of the Intel's the processors, as well as CPU, GPU, and vision processor units are also happening. Some of the things that are becoming very clear is that they would have very almost an embedded TPM, as well as confidential computing, which basically secures your memory allocation, processor allocation, totally encrypted from the rest of the users. So they are being secured very well. And these are more and more common in the next and next generations processors, both on the central processing unit as well as graphic processing unit, and also specialized processing unit like TensorFlow processing unit or vision processing unit, so forth. And of course, your storage virtualization is extremely key point, and how fast it is, because the storage latency has to improve significantly. And I think there are some Opel 2 storage spec, for example, using the SSDs and the NVMe's, and they are reducing those latencies into a significant reduction. And right now they are like going into the bandwidth of almost approaching 4 gigabits and approaching towards the 7 gigabits on the NVMe world, which is basically almost like a memory speed. And then, that's going to be more and more common so that you don't encounter any bottlenecks on this. Now, I'm going to stop in this slide to the interest of time. If there are any questions, please feel free to send me that through the chat box or ask whenever Alex is ready to allow that.